So what we're going to be looking at now is we're going to be looking at how do we utilize derivatives for power series in order to solve problems like of this kind. Negative 2x plus 4x cubed minus 6x to the 5th plus 8x to the 7th, etc., etc. And one of the things, just like working with integrals of power series, is that we're going to have to be able to identify when we are actually dealing with the derivative of a power series. Okay? So what I'm going to do first here is I'm actually going to write this out, write the series out as a series, okay? And so I'm going to look here, and this is going to then be the sum, and we'll take it n equals 1 up to infinity, okay? And this is going to be, it's alternating, so that's one thing I want to look at. It's all alternating, okay? So this is going to end up being negative 1 to the n, negative 1 to the n, times, and then this is going to be, what is that? That's 2 times n, okay? And then that's x times x. And you notice that we've got each one of these is odd. Okay, each one of the values is odd. So we're going to use 2n minus 1 here. Okay, now for odd values or for odd functions, we can always utilize, we can use 2n minus 1 or we can use 2n plus 1. But because I started at 1, right, that's why I use 2n minus 1 rather than the 2n plus 1, right? Because this is going to end up being 2 minus 1, so that's going to be x to the 1, and that gives me my first term. Now what I want to notice here is this, okay? I want to notice that the derivative, d dx, of x to the 2n is in fact equal to 2n times x to the 2n minus 1, okay? That's, if we take the derivative, that's exactly what we're going to end up getting. All right, and that's good news because what that means is that means that this thing right here, okay, is the derivative of x to the 2n. So that's like really, really super handy, okay? In addition to that, we could actually, if we wanted to, we could incorporate in this negative 1, okay? So if we took that and we incorporated in the negative 1, we could say, okay, well, what about that, right? Okay, we're going to now say, all right, let's have d dx, okay. Well, you know what? We'll deal with that in just a bit. Yeah, in just a bit. We won't incorporate it in right now. What we're going to do is we're just going to think about this 2n times x to the 2n minus 1. So now I've got the sum, n equals 1 up to infinity, okay, of negative 1 to the n times, and this is going to be d dx, okay, the sum of x to the 2n. Okay? And that is actually equal to the sum, n equals 1 up to infinity, of negative 1 to the n times d dx of the sum of x squared to the n. And it's at this point that actually I want to move in my negative. I want to actually move in my negative now because what I've got now is I've got both my powers are actually equal to one another. So what we're going to notice is that this thing here, this value, is actually the derivative of this. And this one, I actually am going to be able to find one of our power series, one of our well-known power series for it. Okay? So now what I'm going to do is I'm actually going to move in that negative, right? This is just a constant. And so we can move the constant inward. Okay? It doesn't have anything to do with with x. And so consequently we can move the negative inward. And so this is going to end up being the sum, n equals 1 up to infinity, okay, of d dx, right? Excuse me. No, that's... I want to now just say, okay, so this is going to be d dx times the sum of n equals 1 up to infinity of now it's going to be negative x squared, or negative 1 times x squared to the n, because they're both to the n. So this ends up giving me d dx, the sum, n equals 1 up to infinity of negative x squared to the n. Now, this, in fact, right here is something that we can do, that we can work with. Okay? That, in fact, is going to work. We're going to be able to do something with that. What we want to note is that the sum, n equals 1 up to infinity, okay, of negative x squared to the n, is going to then be 1 over 1 minus negative x squared. Okay? because that's just one of our standard Taylor series. And so this is just going to be 1 over 1 plus x squared. Now that I have 1 plus x squared, I now just have to take the derivative, the d dx. So this is now going to give me d dx times 1 over 1 plus x squared. And this is then going to equal negative 2x over 1 plus x squared squared. And that is, in fact, what this sequence is. That's going to equal then negative 2x plus 4x cubed minus 6x to the 5th plus etc., etc., etc. Okay? So, key to working with this kind of series is to note, one is you need to actually be able to construct the power series. 2, you need to be actually able to notice that this is in fact the derivative. That's the derivative of a term, right? In this case, x to the 2n. So you might have to kind of like, play with that a little bit, okay? But x to the 2n is just, or in this case, when we bring in the negative x to the 2n is just going to end up giving us something that we can work with in terms of our very common table of power series here. This 1 minus x, which we actually sub in the x squared for. All right? Once we do that, then all we have to do is we're now going to take the derivative of that function. All right? So we knew that d dx of x to the 2n was equal to the thing that we actually have. So once we figure out what x to the 2n is as a function, then we can just take its derivative, and that will end up giving us our function here. Okay? And that ends the video.